In this unit, we'll be learning about functions. In applications of mathematics, functions often represent real-world phenomena or events. This is why we call them models. In this chapter, we will look at functions given by formulas, by tables, by graphs, and by words. Let's start by talking about the definition of a function. A function is a mathematical rule that takes certain numbers as input values and assigns to each input value exactly one output value. So you can think of a function as a math rule that tells how one thing depends on another. The input values are called the domain, and all the corresponding output values are called the range. The input values represent the independent variable, and the output values represent the dependent variable. We usually denote functions by y equals f of x. This symbolic form is called functional notation. We read this as y is a function of x. In other words, we input an x into a function and we get some corresponding output value y. This is what we mean by y equals f of x, or y is a function of x. Although I'm using the variables x and y here, remember that you can name your variables, and therefore your function, by any letter. Just make sure to clearly define and label the variables from the start. Let's consider an example of a function. Think of a function as a machine that takes certain numbers as an input value, applies some mathematical operation to the value, and then spits out an output value. For example, let's take an input value of x equals 0. Put 0 into the function, and out comes a value of 0. So f of 0 equals 0. Let's try another input value. Let's put 30 into the function, and then out comes a value of 25.319. So f of 30 equals 25.319. Now let's put 60 into the function, and out comes 20.856. Let's try a few more numbers. Put 90 into the function, and out comes 16.636. And now let's put 120 into the function, and we get 13.255. This function is f of x. Let's look at some of its properties. You just saw my function machine, f of x, take certain numbers as input values and spit out only one corresponding output value. We can denote these values in a table, and as well as on a graph, where we have the x and y axis, and we denote each value of the function as a point, with the x input and the y output. In the table, you'll notice that we have some missing values and gaps in the data. For example, notice that we do not know the output value, y, when the input value, x, is 20. In this unit, you'll learn different techniques, such as averaging or using the average rate of change over an interval to estimate and predict values that are missing in a table. It's important to point out that functions are not always called f of x. You can name a function with any letter. However, it's also important to give precise definitions of the terms and variables we use. The values in the table actually represent the amount of lidocaine in the bloodstream after a certain amount of time. So we could call the input values t for time, measured in minutes, instead of x. And we could call the output values L for the amount of concentration of lidocaine in milligrams instead of y. Now our function can be called L of t instead of f of x. If we collect many more data points than just the 5, a clearer pattern or model will emerge that will help us see how the amount of lidocaine behaves in the bloodstream over time. Once we have a model, we can begin to answer questions such as, how much lidocaine is in the bloodstream after 20 minutes? When does the drug reach its maximum level? And for how long is the drug above 7.5 milligrams? In the next unit, we will learn how to use the TI graphing calculator to answer these questions. In this unit, we will analyze and evaluate functions when they are given to us as formulas, tables, graphs, and words. The following is a formula of the amount of lidocaine as a function of time. L equals 32.89 times e raised to the negative 0.0075731 t minus e raised to the negative 0.12043 t. We will use functional notation to express different values of the function as well as evaluate functions. And in the next unit, we will solve a function at different given output values. For example, if we want to know how much lidocaine is in the bloodstream after 20 minutes, we can write this using the symbols or the notation L of 20. We can find this value by evaluating the function L at t equals 20. We simply substitute 20 into the formula wherever we see the variable t. When we plug 20 into the formula gives us an output value of L equals 25.309 milligrams. We can also express this using the notation L of 20 equals 25.309. This is basically a shorter way of saying the amount of lidocaine in the bloodstream after 20 minutes is 25.309 milligrams. As we've already seen, a function can also be given as a table or graph. In this unit, we will analyze and interpret the table and graph of functions, which will also help us answer questions such as, how does the amount of lidocaine change over time? Is the change an increase or a decrease? Is the rate of change steady or constant? Or does the function change at different rates over intervals of time? Over a long period of time, how much lidocaine do we expect will be left in the bloodstream? Does it make sense that the function approaches 0 milligrams? These are just a few questions we could ask about this particular function. This particular function actually has a limiting value, which is 0 milligrams of lidocaine. The limiting value of a function is the output value when the input value is infinitely large. In the context of this problem, it makes sense that as time passes, if a patient is not given another dose of lidocaine, then we'd expect the lidocaine to be completely eliminated from the body, thus approaching 0 milligrams. In this unit, we will determine if a function has a limiting value, then use a table or graph of the function to find that value and interpret its meaning in the context of a real-world problem. After completing this unit, you will have a good understanding of what is a function and how to analyze, evaluate, and interpret many different types of functions in their various forms: formula, table, graph, and words. Hopefully, you'll come to see that there are advantages and disadvantages to having only one form or representation of a function. Over time, you'll be able to move back and forth between the different representations and figure out which representation best helps you answer certain questions.